Hello, everyone, and welcome to this session on the CRM Stage Conference on DevOps for Salesforce. So, first of all, by way of introduction, my name is Andrew Davis. I'm the Senior Director of Methodology and Training at Copado, also author of the book Mastering Salesforce DevOps. I want to start by saying thank you to everyone for taking the time to listen and learn about this topic, DevOps for Salesforce. And in particular, thank you so much for the team at CRM Stage for continuing with this conference despite all of the adversity in Ukraine, Slava Ukraine. So thank you very much. What I want to cover today is DevOps trends in the Salesforce ecosystem, help people to understand some of the big concepts as well. Why do we need DevOps? How do you measure and visualize progress? And then some basic concepts like continuous integration, continuous delivery. If you want to know more, there are a couple of Trailhead modules. I had a chance to write these together with Copado on Salesforce DevOps and continuous innovation, both. A lot of good information there. So I want to start off by asking this question, why do we need DevOps? And I'd say it starts with understanding that you have a very important job. And I'm speaking to people who are involved in some way in the development process on Salesforce. That the people who build your org, they're actually building your company, that the org, your Salesforce org and the rest of your IT infrastructure is the digital skeleton, the digital structure that supports the company. And that your organization's ability to change, your company's ability to change, say, depends on your ability to deliver digital experiences. So just imagine here that you're a member of this Service Cloud development team and you're building an app. That's a simple job. You're on the team, you build an app. You may not think very often about the full impact of your activities, but if you think about it, the app is being used by someone, say a Service Cloud user, and they're servicing customers. But actually your app is being used by a lot of different users within the organization. They're all servicing customers. And so what this is showing is that directly or indirectly, even in your job doing development and so forth, you're impacting the entire company. So in this way, the dev teams have an exponential impact on the business overall. And if we ask what is the most important link in the chain, I would say that, at least with this view here, the most important thing is that the dev team be able to easily and quickly work on that app, that blue arrow showing that connection between the team and their creativity and their wish to build and create something and the application. How easy is that link? How smooth is that process? For that purpose, you need good tools to do your job. You have an important job, you need good tools. Directly or indirectly, everybody here is probably working on Salesforce platform. Salesforce makes it easy to build. That's what Salesforce's one of their main focuses has been, the platform. Now, easy is great. But there's some conditions that apply, and this is a little bit of a warning or a caveat that there are some troubles with easy. That easy means fast, and fast means more. You work faster, you create more, but more means complex over time. That if you have more people creating more stuff more quickly, it grows, and the bigger the system grows, the more complex it becomes. The vision with Salesforce is that you can take all these individual components, app builder and flows and all this stuff, like Lego blocks, and then eventually you'll be able to build a Lego masterpiece like Salesforce Tower here. But you can think about already, you're probably thinking there's some significant differences between building something in physical architecture and architecting an IT system. Physical architecture, you definitely can take 3, 6, 12, 24 months to build the design and have a lot of architects just look at the design and then start building. But in the IT world, the system is evolving as we're building, right? So it doesn't really translate, physical architecture doesn't really translate into IT architecture very smoothly because it's continuously growing, evolving, adapting. An IT system is much more like an ecosystem or like an organism, or our psychology, for example, how that evolves over time. So when we talk about DevOps for low code or DevOps for Salesforce, the starting off point is when you just have one production org. Now, when you have one production org, from one point of view, life is simple, right? And you spend your days like this, just totally relaxing, no big obligations. But the challenge arises once you've launched your production org and you start getting users, and the number of users using what you've built grows over time. And as the number of users using your stuff grows, the business criticality, the importance to the business of what you're doing grows, but also the demand for changes grow. So if you have 1,000 users, you have so much. So if you have 10 users, your life is simple. If you have 1,000 users, it means that application is business critical, and you've got 1,000 people who have ideas about how you can make it better, right? So the challenge is that when you combine these two, business critical system for the demand for changes, what that does is that it increases the risk of changes. The more, the business criticality in particular is what increases the risk of changes. And the bigger the system is, the greater the risk. And this dramatically changes the emotional environment that you're working in. It's no longer an easy problem. If you've got a lot of people wanting you to change a system that is business critical, it's highly risky, right? So this is where we get into DevOps and moving out of just building in one production environment to have a development, sandboxes or scratch orgs, test environments, then production. And then if you're just starting on this journey, you may think, oh, how hard could it be? We'll just set up some sandboxes, so forth. And so you're like this intrepid hobbit, just off on an unexpected journey. And that's where we're sort of picking up the DevOps story. Now, where things get complicated is that often a lot of the people on our teams are, early in their learning process. We're all early in our learning process relative to where we will be in the future, hopefully. And the initial skills that are required to build on Salesforce are fairly modest, but the systems that we actually have to build to support our companies are very sophisticated. They're like these large, huge Salesforce orgs where the skills that you need are not like basic learning to drive skills on Salesforce. You need system architecture skills on Salesforce, and that's a very different set of skills. The challenges that you encounter include things like keeping all of these orgs in sync. As soon as you have more than one org, you have a synchronization problem. Tracking changes. As soon as you're making changes in an org, you have a tracking problem. Propagating changes systematically, and this is trying to bring some discipline to the process, the software development process. And then as the system grows, the risk of interactions and side effects grows with it. And as a result, then as well, you have to move quickly, and you sometimes build things. Inevitably, you build things in a way that's not. You build things today in a way that's not optimal for tomorrow. And the stuff that was built yesterday is not optimal for today. And that's the challenge with technical debt. And the architecture that we end up with in our Salesforce orgs becomes something like this. Now, if your team has had the wisdom and skill to avoid this mess, congratulations. I probably don't have too much to talk to you about to tell you you're on track. I'm proud of you. But it's not uncommon that teams get themselves into quite a ball of mud with the org. And making changes to that org, instead of becoming like Salesforce Tower, elegantly architected, becomes a lot more like a Jenga tower, where every single little change can put the whole system at risk. When you have a situation like that, people are very reluctant to change. People are very reluctant to build things on Salesforce, right? So that is the challenge that we're trying to avoid here. So first of all, the biggest challenge, when we're dealing with DevOps is how to make it easy to move changes. Now, what I'm showing here is the simple scenario in the beginning where everything's being done in production. You're building stuff, you're testing it, and you're running it in production. Life is simple, like I said. The challenge there, though, is the risk of failures. You bring a great risk of failures, and that can cause revenue problems and lots of other problems. So the first bad option is not having any process at all. Now, when you move to having a development lifecycle, dev sandboxes or scratch orgs, testing environments, and so forth, the next challenge you get is that it's hard to deploy. Now, that may not seem like a big deal, and it may be hard for the development teams to communicate to the business end users or to their own IT management what a big deal that is. But if things are hard to deploy, and especially if you have to deploy data or velocity or CPQ, any of these kinds of things, it's even harder. What that means is you'll deploy infrequently. You will not deploy as often as you might have otherwise. And that means that these deployments will pile up. And when you do deploy, you'll have very large deployments. And with these large deployments, there's a high risk of failures. The more stuff you're deploying at a time, the greater the risk of failure. To avoid that, then people think, oh, okay, well, we've got 500 things we're trying to deploy at the same time. Well, we don't want to have a problem. So to avoid the risk of failures, let's have a big meeting, right? Or meet over several days, or bring all these people together. And then you develop a very big coordination problem. You've moved from a risk problem to a coordination problem. And you think, well, we need to have a lot of manual testing to make sure that we've not broken anything. And that slows the process down again. And you get this, what's called a vicious cycle that slows down the release process. Just brings you back to more and more infrequent deploys and thus larger deployments. But the other problem that happens when you have infrequent deployments is that you get delayed feedback. So you've built something. How long before you get feedback from users on what you built? Is it minutes, hours, days, weeks, months, quarters, years? What happens is that if in any creative process, like even in walking or speaking or whatever, if you can't get feedback, you don't know if you're on track or not. So if developers are building with no feedback, they're just writing code and sending stuff into the queue to be deployed eventually, how do they know they're building the right thing? They absolutely do not. So delayed feedback leads to poor quality. And poor quality, then people try to remedy that with long test cycles. But again, this just piles up the delay. And again, you end up in the same situation, right? Where the company is struggling, you're wasting a lot of money in the IT processes, and nobody's very happy. So bad option number 2 is a slow process. No process, bad option number 1, slow process, bad option number 2. So the first challenge is, how do you make deployments easier? And this is generally where DevOps for Salesforce really gets started, because this is the first problem that everybody encounters. As I go through, I want to introduce some of these general concepts. One of them is known as the theory of constraints. It was popularized by Dr. Eli Goldratt in the 80s for manufacturing. The idea is that in any linear process, the throughput of that process will be limited by one and only one constraint in that system. And that's, in chemistry, that's what you call the rate limiting reaction. And so you have and in the software development world, you've got a bunch of user stories, and those are the inputs, right? And the output is working stuff in production. But how much working stuff can you get running in production? We have no problem generating thousands of user stories. That's not the problem, right? The problem is, how quickly can we develop them and get them running in production? The bottleneck lies somewhere in that whole process. Is it slow to develop them? Is it slow to test them? Is it slow to deploy them? Where is your constraint? Now, the challenge is, let's say your constraint is deployment. You've got slow deployments. If you lift that constraint, if you elevate that constraint and you solve the deployment problem, that's fantastic. You can increase the throughput, but you will still have some constraint. And it may be that testing often becomes the next constraint that teams face. But there's always going to be a constraint, and that's what's called the theory of constraints. Now, typically, when you're building, if you think, what is our goal as a team? It is to deliver innovation, deliver new changes to the organization, help the organization to adapt, and so forth. You've got a lot of ideas. Imagine these little blue dots here are ideas. And the question is, what's limiting your ability to roll those ideas out into production? In the beginning, maybe it's technology constraints. And that's one of the main reasons that people move to Salesforce. Salesforce does a lot of stuff for you, and it makes it easier to build the other stuff. That's the power of the low-code platform. But often, once you get, a lot of companies, when they first install Salesforce, they think, okay, I saw the demos, everything looks easy, but then you realize, I don't know how to do things. Salesforce is very complicated. The setup menus got thousands of items in there. So you may have skill constraints, and that's where you go to Trailhead. And Trailhead's done an amazing job of enabling education for the Salesforce world. And so building your skills can unblock those constraints. Maybe you have team constraints. You're short on team members, and that's where you reach out to professional services organizations. So professional services can unblock that capacity, but at some point, your limiting factor is not going to be the technology. It's not going to be your skills. It's not going to be how many people you've got working. It's going to be the processes. And that's where we talk about DevOps. And in general, in DevOps, it's the tooling and the processes that we're working on unblocking our capacity for. There's a lot that's been said about DevOps over the last 13 years or so. More frequent deployments, shorter lead times, fewer change failure rates, faster recovery times, and so forth. There's a lot of research out there to back that up. And we'll come back to that in a minute, and I'll describe some of the research that we've done at Copado. But I just want to back up and explain a little bit what is DevOps, that term DevOps. Sometimes can be summarized as better value, sooner, safer, happier. There's a popular book, Sooner, Safer, Happier, that talks about that. I happen to have it here on my desk, Sooner, Safer, Happier. But DevOps brings together a variety of topics, both software engineering topics as well leadership topics, process optimization, business process optimization topics. And it's a very, very rich, vibrant community, a lot to learn there. The fundamental term, dev and ops, can be traced back to this idea that there's the dev folks who value change, the ops folks who value stability, and then there's a battle between them. There's a wall of confusion, and traditional organizations doesn't exactly work quite the same way in Salesforce, but a wall of confusion separates these different disparate groups with different motivations, different understandings, different demands on them, and so forth. The idea is, instead of having a battle between dev and ops, we need to find an alignment, a coordination or cooperation between dev and ops, and that's DevOps. Of course, DevOps goes much beyond that. It goes to integrating with all of the other stakeholders and participants in the software development process, as well as the end users and so forth. But the general idea of breaking down divisions that cause misunderstandings and misalignment and so forth between teams, that is critically important at every level. So I want to come back a little bit to measurement and visualization so you can understand a bit more about the kinds of progress that can be accomplished through improving your DevOps processes. Copado and myself had a chance to work on the State of Salesforce DevOps report for the last few years, and we came to a number of conclusions, and you can download the full report from Copado's website. But one is that the technical practices of DevOps in Salesforce are less mature on average than are the technical processes in the broader IT industry, but that the software delivery performance, means the ability of teams to roll out changes and so forth, is comparable in Salesforce compared to other non-Salesforce platforms. Why? Because Salesforce is an inherently stable platform. It's hard to break Salesforce. It's very, very hard to break it. And not hard to break an individual page, your Apex code can break pretty easily, but it's hard to break Salesforce as a platform, and it's pretty fast and easy to run it. But the big challenge comes as teams get bigger. They struggle as they get bigger. Now, I showed you these 4 metrics before on lead time and so forth, and I want to break those down a little bit. These have come to be known as the DORA metrics, or the 4 key metrics of DevOps. They're not the only metrics that matter. They're not always the most important thing by any means, but they're a very useful way to benchmark what we call software delivery performance. And the first 2, lead time and deployment frequency, speak to speed and the team's ability to change. Lead time specifically means, let's say you make one tiny change in development to fix a bug, say, or to enable a slight improvement in a feature. 1 line of code. How soon can you get that code running in production? That's what we call lead time. Once you've made a change, how long before it's running in production? Lead time. Can you make that as short as possible? So can you get that change out there in minutes? If something's really broken, that's going to be very important. Second is deployment frequency. Deployment frequency means, do you deploy once a quarter, once a week, once a day, more often? Deployment frequency is important because deployment frequency implies, if you have very frequent deployments, it implies you're deploying a small batch of changes at once. If you have very infrequent deployments, it means every deployment is a very big deployment. If you have a very big deployment, you have a very risky deployment. And if you If you deploy 500 components and something breaks, you have to find the needle inside the haystack, so to speak. You have to find which of those components or combination of components caused a problem. And that becomes a research project. If you deploy one component at a time and something breaks, where was the problem? It's obvious. It's that one component, right? Just pull that component back out. Small deployments, small batches are inherently safer and faster and easier to train on and so forth. A lot of benefits. The latter two metrics, change fail rate and time to recover, refer to the stability metrics. And I talked to you earlier about dev wants to change and build and create new stuff, and ops wants stability and reliability, predictability, safety. And that these two motivations are inherently in conflict. Like, let's say my wife wants to change things and I like things the way they are. That's an inherent conflict, right? We can't both have that. And so there is naturally a need to reconcile change, the ability to make changes quickly, and the ability to make them without breaking things. Eventually, what we want is the ability to move fast without breaking things. And that's stability. So the change fail rate means every time you deploy to production, how often, what percentage of the time do you break something? The lower that is, the better, because of course, the reason people may be reluctant to deploy to production frequently is because it breaks things frequently. So if you almost never break things when you deploy to production, everyone will be much more comfortable deploying to production. You can enable that change, right? And then time to recover. There will always be a non-zero chance that we make a change in production that will cause a problem. We have to be able to roll that back as quickly as possible. Can you roll that change back in minutes? Or does it take you hours? Or does it take you days or weeks? There's a huge cost to having a delayed time to recover. Anyway, these 4 key metrics are critical. In the 2022 Copado State of DevOps report, the original State of Salesforce DevOps report, we found that the elite performing teams outpace the low performing teams by having 4 times shorter lead times, 46 times more frequent deployments, 5 times fewer production failures, and 8 times faster recovery time. So if you think about the impact on a business of being able to get the changes out 4 times more quickly, have 46 times more frequent updates, 5 times fewer failures, and 8 times faster recovery, your organization will love the dev teams, right? So if the organization is not currently loving the dev teams, it may be because, there's room for improvement in some of these metrics. One thing we found as well, we found this in our research State of Salesforce DevOps report, but this echoes what's known as the State of DevOps report, a broader IT industry survey. The software delivery performance, the performance of teams drives company performance. So the teams with the teams that had a better software delivery performance, easier to make, could get changes out to production more quickly, broke things less frequently, and so forth. Their companies tended to perform better, were more likely to reach their goals and so forth than companies teams that had poor software delivery practice. Okay, so all of that is by way of some foundations on DevOps for Salesforce. Now, to explain DevOps, I need to explain a little bit about dev, but not really, because there's so many other talks in the CRM stage event and elsewhere that explain about Salesforce development. So I don't need to tell you about Salesforce development. I'm going to move on to some of the topics that get discussed less, like architecture. Now, recently, in the last couple of years, Salesforce came out with architects.salesforce.com, and recently a Salesforce well-architected site, both of which are great sources of knowledge. But architecture is always implicit in what you do. It's defined roughly. Grady Booch, for example, listed here. He defines architecture as those changes those decisions which are difficult to change later. And so good architecture is designed to reduce the cost of making mistakes and to increase the ease of making changes later. So whatever decision you're making that will be hard to change later, that's your architecture. So architecture, obviously, you can have system architecture, across the entire enterprise. You can have internet scale architecture. You can have application architecture. You can have code architecture within one file. One key distinction across architecture is tight coupling versus loose coupling. The idea of tight coupling is that all of the different components are very closely related to each other. And that means that if you change one thing, you'll potentially be impacting a lot of other things. And tight coupling is sometimes necessary. I mean, there's always going to be coupling in some way or another in any IT system or any other system, for that matter. But tight coupling can greatly increase the risk. So if you have what we call spaghetti code, where it's just like line after line after line of logic, it's very, very hard to understand the whole system, hard to make a change to one area without potentially impacting a lot of other areas. The opposite of this is loose coupling, and I hope you appreciate my spaghetti versus pizza metaphors. So spaghetti, tightly coupled, you pull one piece of pasta, everything comes with it. Pizza, nice loose coupling. So examples of loose coupling are object-oriented design, modular architecture, and some of the things that enable modular architecture in Salesforce are things like dependency injection, event-driven architecture. These are, somewhat more sophisticated techniques, but they're ways of allowing you to, for example, install a package and have new capabilities arise for an org, and then remove the package without breaking anything else. Add a module, remove a module. That's one of the characteristics. Many people have become familiar with event-driven architecture when building Lightning components, or a component or Lightning components use an event-driven model, specifically so you can add new Lightning components, or they can fail gently, but they don't break the whole page. So that's one example of modular architecture. Okay, so I want to explain a little bit about continuous integration, because this is a term that gets thrown around a lot. And it gets thrown around very, very casually, but many people don't understand the real meaning of continuous integration. But that's not going to be you, because if you pay attention for the next few minutes, you will actually understand what we're talking about when we say continuous integration. But first, I need to explain version control. So version control is the basic foundation for all of the advanced technical practices of DevOps. Why? Well, bunch of reasons, but one is version control gives you the safety to innovate. It allows you to make changes knowing you can roll back to a previous version of things. It also makes it much easier for people to merge their changes if you're working in disparate environments. Makes it much easier then to add automated processes for deployment and testing and so forth. If you want to get started with version control, but it's just very daunting, you can practice what I call defensive version control or passive version control, just setting up an automated snapshot that does a metadata snapshot of your different orgs every day. But real active version control, what a friend of mine calls offensive version control, means where you're actually tracking all of the work that you do. Now, this is one of the areas where, for click-based developers, low-code or no-code developers, using version control can feel a little bit daunting, and that's where tools like Copado make it much easier to have a visual user interface to version control. So to understand continuous integration, so imagine the different environments, and here we've got a simple pipeline, 2 development environments, integration, UAT, production environments. Continuous integration means that all of the work of these development environments needs to be integrated at least daily. And that's really the defining characteristic of continuous integration, is that the changes are being mixed together daily, which means that if one person's working in one sandbox, I'm working in a different sandbox, I get their changes into my sandbox every day. Maybe at the start of the day, there's an automated process that deploys it, or I manually merge it into my environment. But that becomes critically important because it basically is breaking up the code base and making it more fluid. So all of the changes are recirculating, and this becomes particularly important. The situation where you've got long-running projects, you've hired an SI and they're going to work for 6 months or 12 months or something like that in total isolation from everybody else. They're building something and they're going to try to deploy it to production. You always have big issues, right? Because their system has become different, substantially different from the system, from the actual running production environment. So the purpose of continuous integration, let me frame it for you a different way here. So continuous integration lies on this spectrum between instantaneous integration and eventual integration. These are my terms for that. Somewhere in the middle. So if everybody on your team is developing in the same sandbox, you have one development sandbox and everybody's in there, you have instantaneous integration. If I make a change, you see it immediately. Now, that actually is a totally legitimate way to go about things, but it does lead to a couple of problems. There is the risk of losing work. Somebody else could overwrite something that I did. Also, it's hard to isolate problems. So I'm debugging something and I had a problem, and I keep trying to figure out where it is in my code that something's broken, but I don't realize that you've made a change in the same environment that's causing that problem. You can waste a lot of hours with other people breaking things. So if you're doing instantaneous integration in the same environment, it can be too unpredictable. And that's one of the reasons why people tend to move to, over time, if you have a big enough team, you move to isolated development environments. If you see down here, these isolated development environments like scratch orgs or sandboxes, these can give you a little bit of separation. So you have multiple different developers or different teams in different environments. So you're not having that chaos, that too unpredictable stuff. But that leads to this other problem that I'm mentioning, that if it's, you're only integrating changes every week or months or year or whatever, you have these very, very, very painful integrations, a lot of wasted work. And also, it is impossible to refactor your code base. And that's what I mean when I say making the code base fluid. And when I say code base, I mean also all the declarative changes that are made, the objects and flows and whatever else. To refactor means to change the underlying way you've designed the system without breaking the existing functionality. Refactoring is necessary to keep a healthy code base. Just like cleaning your room is necessary, definitely necessary. As I look around my room, I need to give it a good tidy, but stuff piles up. And occasionally you need to reorganize. I'm going to move this here, move that there. So if you have isolated environments and you don't have a smooth way of recirculating the changes, it becomes too inefficient. So you can see continuous integration sits right here in this sort of sweet spot in the middle. And ways to accomplish continuous integration are using things like automated back promotions. This is a capability that Copado has to automatically deploy changes from one environment to another, or things like automatically creating environments. That's one of the goals of scratch orgs or sandbox cloning, is to auto-create those environments. And activities like process automation, working in small batches, also enable continuous integration. Now, but what happens is, as teams are trying to work safely in a continuous integration environment, you're moving changes in every day. I'm bringing in changes from other environments. Imagine that I've got 5 other development environments that I need to synchronize with, or 100 or something like that. My environment's changing very, very quickly. Do I get any warning when things have broken? And that's what brings in testing. And so when we talk about testing, we need to understand the different levels. If you think about an iceberg, what the business request is up top. What you've built is down below. And so when we think about quality and testing, we're actually talking about different levels of quality. So functional quality is just testing something to make sure that you haven't broken it. Does it do what it's supposed to do? Automated testing. But structural quality means testing all of these aspects of the system that are below the surface. So is the system reliable? Does it always return the right results? Is it secure? Is it performant? Is it maintainable? Easy to maintain? How big is it? Can we make things as small as possible? One of the big benefits of Salesforce is because they have so much built-in functionality. If you can replace something that was custom built with something that's just built into Salesforce, you're greatly reducing the size of customizations that your team has to maintain, and therefore you're greatly reducing the surface area of problems. It actually has a big positive impact on quality when you have somebody else is maintaining that underlying system and it's not something you have to think about. This brings us to the next topic, which is continuous delivery. So sometimes people talk about CI, CD, continuous integration, continuous delivery. We throw these acronyms around very casually, but these are very deep topics. And it's actually pretty hard to implement. Both of these requires some skill and work. So continuous delivery deals with, it in particular has to deal with this issue of environments getting out of sync over time. And in particular, the more environments you have and the slower it is that changes move through, the easier it is for those environments to get out of sync. And this phenomenon is what's known as configuration drift. Configuration drift, to understand this, imagine from production, you clone 2 sandboxes from production for 2 different developers, and you assign those 2 sandboxes to 2 different developers. Initially, those environments are exactly identical. But as soon as people start working on them, they begin to differ and they vary. And the longer those environments remain active, the longer the sandboxes live without being refreshed, the more they differ from each other. And to some degree, you can control that by tracking work and version control and deploying it and back promoting it and so forth. But to some degree, those differences are going to add up. And so that's why you occasionally need to burn it down, refresh your sandbox, clone the sandbox, build a scratch work, those kinds of things. So continuous delivery has a lot to do with this configuration drift. So whereas continuous integration deals with this sort of left-hand part of the lifecycle, continuous delivery deals with the entire development lifecycle, especially this right-hand side. How quickly, instead of the question being with continuous delivery, well, whereas with continuous integration, the question is how quickly do changes move from one development environment to another development environment, and how fluid is the recirculation of changes across those development environments. The question with continuous delivery is how quickly changes move from development to production. And certainly if there are changes being made directly in production of any kind, how quickly do they make it back to the development environments? If you have very good continuous delivery, the environments stay relatively in sync and there's a lot of fluidity and everything sort of equalizes and normalizes. If you have very poor processes, lack of continuous delivery, then you'll get these massive out of sync environments and long delays in trying to get changes out. So without going into detail, you can see that a continuous delivery is the opposite of occasional delivery. If you're delivering only every few weeks or months, then everything is aging and there's a lot of problems and limitations to your ability to roll those changes out and get feedback. And this is kind of taking you back to that initial diagram where I said, if it's hard to deploy, you get poor quality. And that's one of the main things that continuous delivery is trying to address. So when we talk about the delivery pipeline, this is actually a screenshot taken from Copado. It's a way of visualizing this delivery pipeline. I can draw diagrams in Google Slides or Lucid Charts, something like that, but there's nothing quite like seeing a live, active depiction of the real environment. That's one of those things that a graphical tool like Copado will bring to you. So we've talked about dev, talked about DevOps. I want to talk about ops a little bit. Now, Salesforce Ops, really Salesforce is doing all the hard work for you. And that's why companies pay a lot of money to Salesforce for the licenses, is because they're basically paying Salesforce to maintain the production systems for us. Whereas if you have entirely custom applications, custom databases, these kinds of things, you've got to hire specialists to maintain those, keep them healthy, bring them back up if they fail. With the cloud applications like Salesforce SaaS applications, they're maintaining that for you. And so the role of ops or admins in the Salesforce ecosystem is very different from network admins or server admins. Salesforce admins mostly work as click-based developers, as you probably know. But these click-based developers, their opportunity then is to be perhaps a lot closer to the end users, getting feedback and so forth, because they can move more quickly. They can be learning directly what the users need. And it can be very, very tempting for an admin who has, if they've been given admin access in production, it's very, very tempting for an admin to just make changes directly in production. But what happens is if you have anybody making significant changes directly in your production Salesforce org, it can cause enormous problems for the rest of the development lifecycle. So by all means, create all the reports you like and report types and maybe list views and some of these other safe, low risk things. Nobody should be changing the data model of Salesforce live in production. If you have a sophisticated enough system that you have a lot of developers using sandboxes and so forth, every single change, including adding, removing fields, doing flows, those kinds of things, they all need to be flowing through the development lifecycle so that the developers have their changes being staying in sync with the production changes. Otherwise, you get this configuration drift that I was mentioning. You have deployment errors, you have all kinds of issues when your production environment drifts away from the development environment. It just slows everybody down. So what you need is a very, very fast, very fluid system for moving changes from dev to production. That is what enables a high-performing development team. Now, sometimes if you have existing practices, maybe developers have been using change sets to move their changes slowly, or you're on a simple tool like Salesforce DevOps Center or something like that, and it's not quite meeting your needs. Or you're trying to get your admins to stop making changes directly in production, you've got to bring about human change management. So this is a very interesting process because humans, all of this previous discussion has been about changing IT systems. Now we're going to talk briefly about changing human systems, social systems, psychological systems. They work very differently than IT systems, as you may be aware, right? So if you're trying to bring about new processes, new behaviors in a development team, you need to understand some of these things like this. On the left, I've got this graph called the technology adoption lifecycle. And in any technology, typically there's some innovators over on the left. I'll show you here, these innovators who they want the newest, fastest, coolest stuff. And you've got a certain percentage of the population that just wants to do something like automated testing because it's the coolest, fastest, best way to do things. But the majority of people live over here. They're not particularly rushing to adopt new practices. They're only going to adopt new practices once they've been proven. And that leads to this, what's called a chasm, which is this gap between the things that get the innovators and the early adopters really excited, like automated testing is the fastest way to make sure that you're not breaking anything in Salesforce. And it gives new skills for your manual QA testers to learn and so forth. Some people love that stuff. They just want to be better, better, better. But if you want to get everybody in your organization to be able to adopt some of these practices, you have to change your approach and you have to prove out success with a small group and then begin to advertise that success and begin to get more and more people interested in these other groups who are not adopting because it's the fastest, best thing, but they're adopting because other teams have had success and other teams have worked through all the kinks and so forth. So it's totally normal if you think that if you see some groups are more advanced in your organization than others, totally normal, right? We just have to help the rest of the folks get further along. And eventually these laggards and so forth, they're not going to do something unless they're absolutely forced to do it. So at some point you shift over to having to just basically say to everybody, listen, nobody's making changes directly in production. We're locking you all out. Everybody has to go through a development lifecycle. But you want to approach that gradually. I'm not going to go into this 8-step sequence, but if you look, I've got a book, Mastering Salesforce DevOps, that at least briefly summarizes this change enablement process. That's very, very important to follow. So my final words of advice for you are, this is a process. It's a human process as well as a technical process. You need to learn how to communicate well, and you need to be bold. And this is my advice to you. It's my advice to myself as well. If I think about the bravery that's being shown by all kinds of people in Eastern Europe these days, it is extraordinary and inspiring, and so it helps us to reflect on the good fortune. If you're not in a crisis situation, you think, listen, I can bring about effective change for my organization. If some people can go through terrifying challenges in their life, I can make beneficial change in my organization. So we can take courage from the people who are embodying and demonstrating courage, because even making little changes like speaking up in a meeting or suggesting something, there's always a psychological risk. There may not be a physical risk, but there's a psychological risk. And that's where we need to be encouraging each other to be exploring, innovating, and then having a good time. Because this is great fun if you get a taste for making these kinds of improvements. So finally, I'll make a shout out to this book, Salesforce Mastering Salesforce DevOps, if you want to learn more. And then in particular, check out Copado and get a demo of Copado if you want to see how some of these tools that make it easier to put these changes into effect. So thank you so much. Appreciate your time.